for example, you may be asked to evaluate or to simplify an expression like this. Let's just make another fraction. It looks kind of similar to this using numbers. Let's say we're talking about 4 plus, say, 12 over 4. Okay? Well, we know that the answer to that is actually equal to 16 divided by 4, which is, the answer is actually 4. Okay? I can rewrite this. I cannot do that, by the way. That makes no sense, because that would mean if I did that, the answer would be 12, and it's not 12, obviously. I can rewrite it like this: 4 over 4, that's this bit here, plus 12 over 4. And that's equal to 1 plus 3, which again is equal to 4. So that's correct. So I can do certain things with the fractions. So based on that, I could go that I have the square root of x divided by the square root of x, which you know is equal to 1, plus the square root of x cubed divided by the square root of x. We can immediately make that as 1, because anything divided by itself is 1. I like to rewrite these things as in powers of of fractions. So x to the power of 3 to the square root of it is equal to x to the power of 3 divided by 2, where the 3 refers to the cubed and the 2 refers to the square root. And then it's divided by x to the power of a half. When we are dividing powers, we subtract the indices. So the answer is going to be 1 plus x to the power of 1, because 3 divided by 3 over 2 minus 1 over 2 is 2 over 2, which is 1 plus x. So this is my answer here. Okay, hope that helped. Next one, we'll go on to the next question. Okay, so now we're trying to solve the equation. So we're trying to find what value of n makes it true. Just to remind you, if I have 3 to the power of x is equal to 3 to the power of 4, well, I know that x is equal to 4. So what I'm trying to do in this case is I'm trying to work out, I'm trying to get both of these numbers, left and right, to have the same base. So the base is going to be 3. So 27 is 3 to the power of 3 to the power of n plus 2. And that's equal to 9 is equal to 3 squared to the power of 3n plus 2. Okay, when 3 to the power of 3 is raised to the power of n plus 2, I multiply the indices. So that's going to give me 3 to the power of 3n plus 6. And that's equal to 3 to the power of 6n plus 4. Okay, so just in case you didn't see it, the 2 is multiplied by the 3n plus 2, gives me 6n plus 4. And the 3 is multiplied by n plus 2, which is 3n plus 6. So now I can say that 3n plus 6 is equal to 6n plus 4. So 3n plus 6 is equal to 6n plus 4. Getting my n's onto one side, I'm going to get into 3n here is equal to 2. So n is equal to 2 divided by 3. I've just realised, by the way, that the question in the test paper was 2n, it was 27 to the power of n minus 2. So obviously I'm getting a different answer to that. But that's the technique for doing it. And then so in my case, n is equal to 2/3. If you plug in 2/3, and you should do this if you're doing a test and you have time for it, plug in your 2/3 into this equation to make sure that 27 to the power of 2/3 plus 2 is equal to 9 to the power of 3 multiplied by 2/3 plus 2. And it will be, I guess. And by the way, it's good practice to do that anyway. And also, that's also called verifying. So if they ask you to verify, you must do that. Okay, and let's move on to the next question that was in the paper. In this case, we're asked to rationalise the denominator of this particular number here. This is a 5, by the way. Rationalise the denominator means that we try to turn this into a rational number, and the square root of 80 and the square root of 5 are not rational numbers. A rational number is a number that can be written as a over b, where a and b are elements of the integers, okay, and b is not equal to 0. So that's what it means. It can be written as a fraction of integers. So in order to do that, what we do is we multiply it by the conjugate of the denominator, which is 80 minus root 5, well, root 80 minus root 5, and I multiply that, divide it by root 80 minus root 5. You'll see that root 80 minus root 5 divided by root 80 minus root 5, that's equal to 1. So I'm multiplying my original fraction by 1. I've chosen to make the 1 out of the conjugate of this number here. So let's multiply it out now and see what we get. We're going to get root 7 by root 80 minus root 7 by root 5. I'm not multiplying anything out yet. I'm not making it root 35 just yet. Now I'm going to get 5 by 80 plus root 5, root 5 by root 80, and then minus 5, root 5 by root 5. On the bottom, I'm going to get root 80 by root 80, which is 80. I'm going to get a root 80 by minus 5 and a root 80 plus 5, plus root 5. So they cancel each other out. And I'm going to get a root 5 by minus root 5, which is minus 5. To remind you, they're looking for the answer to be in the form of a plus b root c, where a and b and c are all elements of rational numbers, elements of q. So they're rational numbers. They can all be written like a divided by b as fractional numbers. So they're looking for this. So this particular solution, that the correct answer, we've rationalised the denominator, but we haven't written it like this yet. So we need to continue to simplify this. So let's look at roots, the first one. Say root 7. Now root 80 is equal to 16 multiplied by 5. 80 is equal to 16 multiplied by 5. So the root of 16 multiplied by 5 can be written like that. Minus root 7 root 5 plus root 5, and then 80 is equal to 16 by 5 again. Minus 5, all written divided by 75. I'm going to change colour again because it helps not get the lines mixed up. Now root 16 is equal to 4. So that's going to be 4 root 7 by root 5 minus root 7 root 5. And I've got root 7's root 5s here, which are looking pretty good. Then I'm going to get 5 by 4, which is 4 times root 5 by root 5 by root 5. That's looking like 5 minus 5. This here is equal to this. I took the 4 out, and then I'm left with the root 5 inside and the root 5 on the outside, which is going to give me 5. And it's all divided by 75. And let's get this as a bit of room here. Now, that's going to give me 4 root 35 minus root 35 plus 4 by 5 is 20 minus 5 over 75. 4 root 35 minus root 35 is 3 root 35. Let's change colour again. 3 root 35 plus 15 over 75. So that's going to give me, now I want to write it in the form of a plus b root c. So let's move my root. So that's going to give me 15 divided by 75 plus 3 root 35 divided by 75. And I can clean that up a little bit. 15 goes into 75. I think it goes in 5 times, doesn't it? Yeah, so it's going to be 1 over 5 plus, and 3 over 75 is 1 over 25 by root 35. Okay, so this is written in the form of a plus b root c, where a and b and c are all integers, okay, or rational numbers, not integers, rational numbers. Okay, I'm now going to plug in these answers to make sure I get the right solution, which you should do as well. Make sure you just haven't made any simple typos, which are easy to happen. Let's try it out. And I just checked that number is correct. So we've actually solved that problem. And finally, there's one problem on logs. Let's have a quick look at that as well. Okay, when we're dealing logs like this, the log, when you add logs together, for example, log of 100 plus log of 1,000, I can rewrite that as being log of 100 multiplied by, that's supposed to be 1,000, multiplied by 1,000. Okay, because the answer to this is equal to 2, and the answer to this is 3, and so therefore 2 plus 3 is equal to 5. But if I get the log, this is to the base 10. When you don't express the base, it's assumed to be base 10. So log of 100,000 is actually equal to 5. So it's the same thing. So over here, in this case, I can multiply these together as well. So this, I'll do it in blue. That's going to give me log base 10 of 17 minus 3x times x. And that's all the log of all of that. And that's equal to 1. Okay, now using your laws of logs, that means I'm saying what power must 10 be raised to give you this? What power? Now we don't know what power 10 must be raised to give you this, but the answer is 1. So therefore 10 to the power of 1 is equal to 17 minus 3x by x. So that means I'm going to get 10 is equal to 17x minus 3x squared, which looks like a quadratic. So I'm going to make it 3x squared minus 17x plus 10 is equal to 0. And then you want to get the roots of that, find out what values of x solve that. I'm going to try use it by using factors. I want 5 here and 2 here. That's just experience by doing this. So 5 by 3 is 15 and 2 by 1 is that. They're both going to be minuses. So I know that 3x minus 2 is equal to 0, or x is equal to x minus 5 is equal to 0. So x is equal to 2 over 3, or x is equal to 5. So you've solved it. Both of those equations are okay. Both of those values are okay. If you were to plug those two back into this original equation up here, you would find that the log of 10, 17 minus 3, wherever the answer was, plus log of that, it would indeed be equal to 1. So that's how you solve that particular one here. The solution was recognizing that you can multiply them, and then you need to recognize that this is expressed as 10 to the power of 1 is equal to this. So you just need to look at your log rules. If you don't know it, it just means you haven't looked at the rules properly. And then you get a quadratic and you solve it. Okay. Just one last small point. If you cannot solve it using your factors like this, you can use the minus b formula. Use the minus b quadratic because you're trying to find what values of x will solve this equation. So that will work as well. Okay, hope that helps. Thank you.